Now let us start with module 5. Module 5 basically deals with display devices and recording devices. One half of the module deals with display devices, the other half deals with recording devices. As we can have a look at the syllabus here, it deals with introduction, character formats, segment displays, dot matrix display, bar graph display, cathode ray tube, LED, LCD, Nixies, incandescent, fluorescent, liquid vapor, and visual displays. Then the other half, strip chart recorder, galvanometer recorder, null balance recorder, potentiometer type recorder, bridge type recorder, LVDT type recorder, circular chart and XY recorder, digital tape recording, and UV recorders, and at last ECG. So let us start with the display devices section. First we have segment displays. In segment displays, we have 7 segment display, alphanumeric display, dot matrix display, and bar graph display. So coming to the 7 segment display, we have 7 LED segments used for displaying numbers, and this will be used in several digital drivers, and there are 2 connection topologies. One is common anode type configuration, the other one is common cathode type configuration. So basically, whenever we take an LED, it is also as good as a normal diode that emits. The normal diode we take, whenever it is forward biased, it emits the energy in the form of heat. This LED, when it comes to light emitting diode, it emits the energy in the form of heat as well as light. So whenever a light emitting diode is forward biased, it will emit light. So here we have common anode type configuration and common cathode type configuration. So in common anode type configuration, we have plus VCC, and we are having A, B, C, D, E, F, G, H, 1 for decimal point. So totally we have 1, 2, 3, 4, 5, 6, 7, 8. 8 diodes are present here, and a small internal resistance is represented, and anode is connected to plus VCC. Cathode, depending upon the required segment to be displayed, will be connected to the cathode, such that whenever the LED has to be forward biased, cathode is to be connected to the negative, and plus VCC is connected to anode. So then required LED which has to be turned on will be rendered forward biased by connecting the required LED to the negative supply. The other configuration is common cathode type configuration, where all the cathodes are shorted and given to the ground. Required LED to be turned on will be connected to plus VCC. That is, required anode of a particular LED will be connected to plus VCC and it will be turned on. Then coming to the actual working, the output of the digital circuits will be BCD, binary coded decimal, and then we have BCD to 7 segment decoder circuit, and we can see all the LEDs here, and it is working in common anode configuration. It's connected to plus 5 volts, which is acting as VCC, and this represents the display unit. We have A, B, C, D, E, F, G, and then it is a decimal point. So we have LED segments here, which forms a number. So depending upon which number has to be turned on, accordingly the corresponding LED will be forward biased. For example, let us consider we want it to display 0, then we need A, B, C, D, E, F to be turned on. Then only it can they should turn on such that 0 will be displayed. A, B, C, D, E, and F. So here that is digit 0. Binary coded equivalent is 0000, and here it is active low input. So A, B, C, D, E, F is 0. G and DP are 1. Whichever LEDs have to be turned on, there will be zeros. Whichever will be turned off will be 1. This is because it is active low. Similarly, the remaining numbers, depending upon the digit to be displayed, corresponding LEDs which have to be turned on will have active low input. So let us take the last example, that is number 9. When it comes to number 9, BCD equivalent is 1001. So in this display, we can see that if 9 has to be displayed, then AFGBC, AFGBC, and then D must be on. So they all should be 0. So you can see here A, B, C, D, F, G are zeros. E and DP will be in off condition. So E and DP should not be on. So it is 1 here. So this is how we'll be using LEDs for 7-segment display. Next we go for alphanumeric display. Alphanumeric, as the name says, we can display both alphabets as well as numbers. And this is how the arrangement looks like. It is a 14-segment display because you're going to use 14 LED segments. Unlike the previous one where we use 7 LED segments, here we will be using 14 LED segments, and it will display both numbers as well as alphabets. I have just shown a simple example here, A, B, C. Similar to what we have seen in the earlier case, the LED bits that must be turned on will be active low, and it will be driven and forward biased. Then we go for dot matrix display. So in dot matrix display, each dotted end, the LEDs will be arranged in matrix form. So it is called as matrix display with the number of rows and columns, and the combination of dots basically will indicate the alphabet or number, and behind each dot there will be an LED. So the corresponding LED, when it glows, a dot is highlighted or illuminated. So there are different matrix here, 3x5 dot matrix, 5x7 dot matrix, and so on. We can see here we are displaying 1, 2, 3, and 4. So corresponding LEDs will be turned on. LEDs that is behind the dot will be turned on. Again, we have 5x7 matrix type. You can see A and C been indicated here. Then we have bar graph display. This is another kind of indicative analog based display where the actual digit will not be displayed, but the value, whichever has to be highlighted, will be this LED will be basically used as a highlighting device here. The corresponding digit, next to the corresponding digit, the LED will be highlighted. So the basic application is panel meter, water level indicator, and water level controller. You can see high, middle, low. Corresponding LED will turn on based on the input from the sensor. So this is called as bar graph display. So these are the different display devices we have under segment displays: 7-segment, alphanumeric, dot matrix, and then bar graph display. Next we go for second display device. See, all these things that we have covered so far comes under segment displays. Second one is liquid vapor display. So this is the arrangement for liquid vapor display. In this liquid vapor display, we have glass plates on either ends. At one end, the glass at this is called as a rear end, this is called as the front end. At the rear end, it is painted in black, and at the front end, the glass is basically roughened by scraping it. This is basically shown here. The roughened part of the glass is shown here, and then we have a thin transparent electrode that is inserted into this, and we have this particular unit immersed in liquid. That is, liquid is added into this particular container. On one end of the container we have black painted glass. On the other end of the container we have scraped part of the glass, and in between we have a transparent liquid. And then we insert an electrode, which is a conducting material. Thin transparent electrode will be inserted, and it is connected to a switch. Through a switch it is connected to the battery, and then this is the viewing direction basically. So under normal circumstances, so this is the same thing I have talked about, the arrangement over here. Inner surface is roughened by scraping it, etc. So whenever the display is basically in off condition, when viewed from front glass, the black background is seen. Since the liquid happens to be transparent in nature, when the display is in off condition, that is when the supply is not given, the viewer can clearly see from the front of the glass. He'll be able to see this black background, so it will be completely transparent. Now when the switch is turned on here, when the switch is closed, supply is given to the electrode, and then uh, the liquid in the vicinity of the electrode basically evaporates and vapor bubbles are formed. So here in the vicinity of the electrode, whatever liquid is there, that will evaporate, and we have no place for the vapor to escape. So vapor bubbles are formed around this particular electrode. Whenever light falls on this vapor bubbles, it scatters inside the screen. So it strikes the vapor bubbles and scatters, and the entire device will get illuminated. It will act as a display device. So this completes liquid vapor display. In the next session, let us continue with the remaining devices.